Hello everyone, welcome to the course Data Structures. This is Thulasi Chitra, Associate Professor, Department of CSIT, MLR Institute of Technology. Let us see the overview of today's course. Here we will be discussing regarding searching, then types of searching, then followed by examples on linear search, right. Let us see what is searching. And with that, we are going to see one more concept also and how we are going to implement this linear search. Let us go for what is searching. This is a definition where you can know about what is searching is. Searching is a process of finding a value in a list of values. Suppose we have a list of values, consider 20, 40, 70 and 90. These are the list of values where you are going to search for a particular element. Consider you are going to search for element 70. Whether this element 70 is present in this list or not. If you are going to do so, if you are going to find that particular element, this is nothing but searching. In other words, we can say searching is a process of locating a given value position in a list of values. Not only finding the element, we are going to find that in which position it is present. That is the 70 present in which position, that one also we are going to return. Okay. This is nothing but searching. And what are different types of searchings we have? Here we have three different types of searching techniques. One is linear search, another one is binary search, and the last one we have is hashing. But here we are going to discuss only two types of searching techniques. One is linear search and binary search, and this is one more advanced one. Now we are not going to discuss about that. Okay, let us see what is linear search here. Here we will be seeing about the algorithm, how we are going to perform the linear search. Linear means linear, or we can name this as a sequential search also. That means in the continuous way we are going to search. What are the steps that we require in performing linear search? Step 1. First, we are going to have a list of elements as I have shown you in the example 20, 30, 70 or some 100. These are the elements where we are going to have. And the next step, the first we need to have a list of elements, then we need to search for the search element from the user. After taking a list, we need to take a search element from the user. Suppose I have taken it as 70, right? This is the element which I have read from the user. Compare the search element with the first element in the list. First, I am going to compare with the first element in the list. If there is a match between these two elements, then we can say that element found in the list. Otherwise, we are going to repeat this process until the end of the list. This is the process where we are going to do. Now, you see the statement, if both are matched, then display given element is found and terminate the function, right? If the element is found, we are going to say that the element is found at a particular position and we are going to return back to the function. Otherwise, if both are not matching, in the previous case itself, 20 and 70, both are not matching. In that case, then compare search element with the next element in the list. Now, what we are going to do? We are going to compare 70 with next element. Next element is 30. We are going to compare these two. Again, if both are matching, we are going to terminate and return its position. Here these both are not matching. That's why again we are going to search with the next element in the list. Next element is 70. Yes, now both are matching. Now, so that we can terminate. Now, you see, compare search element with the next element in the list. This process has to be done. Repeat this step 3 and step 4 until search element is compared with the last element in the list. Until the last element, we have to repeat this process. If the last element in the list also does not match, here I found a match, right? If we don't find an element in the list, then we are going to display that element not found in the list. This is the process where we are going to do in the linear search. Linear search or sequential search, both are the same. Now, let us take the example here. Consider the list of elements and the element to be searched, both the things we are going to give, and based on that, how this algorithm is going to search the element in a sequential manner, we will see. These are the list of elements where it consists of totally 8 elements, right? and the search element is 12. Now start searching from the first position, that is from index 0. What is the element we have? From there we are going to search the element and the key element with the key element, right? This is the key element. Now search 12 is compared with first element 65. Now these two are comparing, both are not matching. Now we need to go for the next element and we need to search. The next element is 20 and 12, both are not matching. Now in step 3, now both are not matching means we need to move our I value to the next position, and so that we are going to search with the next element, right? Now we are going to search element with the 12 and 10. These two are going to be compared, both are not matching again. Repeat the same process. We need to move to the next location. Next location we have 55. I am searching with the 12. Both are not matching. Next we are going to move to the next location, that is 32. Is the next element which is present in the list, and check with the search element 12. Both are not matching. Again we are shifting to the next position, that is 12 at index 5, right? Now both are matching, so that we are going to stop here and we are going to return its index. Both are matching, we are going to return its index. If not matching, then we need to search for until the end of the list. This has to be done, right? Here matching is done, so that we are going to return its index as 5. Now let us see the analysis. The analysis is nothing but how much time it is going to search a particular element in the list by using linear search. Time complexity involved to search an element matching a key in the input list for the worst, best and average cases. The time complexity is going to be measured based on the worst case, best case and average cases. 3 cases are there. Best means in the first checking itself, if you are going to find the element, then it is called the best case, and average and worst almost the same, right? Based on that element, how many times, how many comparisons we are going to do, that will return the worst and average cases. And here for the best case, if in which the first comparison returns a match, as we have seen 20, I have taken the element as 20 itself. In the first in the list I have 20 and my key element is also 20. If both are matching, at the first step itself I am going to have a match, so that it requires only a single comparison, and hence it is called the best case. And here we are not doing much more comparisons. The comparison we have done is only one. That's why it is going to be represented with the time complexity of big O of 1, right? And in the worst case and average cases, how it is going to be done, let us see. If there are n items in a list, we have seen some 4 items, then it is obviously that is a worst case. Until the last we are going to search. N comparisons are required, hence the worst case performance for this is big O of n. N elements are there, n searches or n comparisons we are going to do, so that we are going to have big O of n. This is the time complexity for the worst case, and the linear search will take big O of n. And in the average case also, the average time depends on the probability that the key will found in the list. Thus the average case roughly requires n by 2 comparisons. It may find at second position or third, 4, 5 in any index. If it is going to find, we are going to take the average of it. That means it will have n by 2 comparisons. That means the average, and as in worst case, is proportional to n, hence it is big O of n only. Next, as I said, worst case and average are almost similar in the linear search, and the best case is in the first search itself we need to find the element, that is big O of 1. And this is how where you are going to perform the implementation of linear search. Let us see, here we have not written the main function. You can able to write the main function where we can read the values, and we are going to check for, we are going to read the list of array elements, and we are going to read the search element also, as we have seen in the algorithm. These 2 things has to be done, and that has to be paused in the function. Not only that, we are going to read the n value also. These 3 things we need to pass it from, we need to read it from the main function, and from there we need to pass, right? We can write the main function, and after that when you are going to call for the sub function, what we are going to do, we are going to call for the linear search function. Here this can be, linear search can be done in 2 ways. One by using functions itself, by using a recursion function as well as using a non-recursion function we can do. Here the part which you are seeing here on the right hand side, this is called the recursion function, where the function calling itself. And here this one which you are finding on the left hand side, this is nothing but a non-recursion function. That means here we are not using any function which we are not calling recursively, right? And here if you can see, we are going to read the array n value and key value. These three values we are going to read it, and we are initializing I and flag value to 0, right? And we are going to perform the linear search. How? One by one in sequential order we are going to search. We are moving from one location to another location if there is no match. For that purpose we are using this loop, and we are going to check with the key value. If the key value is found, we are going to terminate the loop by using break statement. If the key value is not found, then automatically it has to check for all the elements in the list and then it has to terminate. In that particular case, it has to return the key element not found. If the key element found, then it has to go with the flag value equal to 0 and key element found at a particular index. We have seen at the previous example, we have found the element at 5th position. Like that way, it is going to return the index value at where the key element is present. And here in the recursion process, same, we are going to pass the array n value and key value, and here we are not using any loops, just we are going to use if and else conditions. And here where you can see, this is a recursion function. This is a function where you are going to call the function recursively. We are not having any loop iterations here. By using this function, this will be calling recursively until all the elements are going to be searched. Okay, this is the recursion process. And let us see what we have seen in this today's session is what we have seen about what is searching, what is the definition of searching, and what are the different types of searching techniques also. Linear search, binary search, and hashing we have discussed. These are the categories where we have seen, and we have seen one example how we are going to perform the linear search, and we have seen the implementation of linear search also. I hope you understand this concept. Thank you.